Hi, I'm Justin Berggren for AVIA422, the Precision Instrument Approach, or the Instrument Landing System ILS. So coming back from a weekend in Vegas, we're trying to get back to the California coast. The weather is still socked in, and we've got ceilings about 400 feet. Unfortunately, our standard GPS approach won't let us get into the airport. However, an ILS coming down to 200 feet will allow us to get home. So that's kind of a great scenario where we can see how beneficial an ILS can be. So an ILS has a localizer and a glide slope, so it provides lateral and vertical navigation. So we're getting both left to right and up and down guidance. Typically, it's a 3-degree glide slope. As the aircraft gets lower, it actually gets more precise as well, which makes this an incredible tool. And typically it can allow us to get all the way down to 200 feet above the touchdown zone elevation. And I think it's easier to fly. The downside of it, it's expensive to maintain, and so for that reason, it's usually only found at busier, slightly larger airports. So if we live in the middle of nowhere, odds are you're not going to have one, but your next alternate might, which is a great tool to have. So when it's available is the standard approach assigned by ATC. The approach lights may be installed on a runway, which will help us get down easier, give us more visual references so we can see. So I mentioned that the localizer provides the lateral left to right guidance. It is located past the departure into the runway as we're approaching. And so it consists of two lobes. We've got the 90 Hertz and the 150 Hertz. And the 90's on the left, 150's on the right, as we can see from this diagram here. And when the receiver in our aircraft is getting both the same amount of 90 to 150, we know that it's centered. If we get more 90, then we're drifting left. If we get more 150, we're drifting right. And the receiver will feed us this information by the CDI needle. And the glide slope works pretty much the exact same way. It's basically a localizer on its side, angled at a 3-degree angle. And so it works the exact same with the 90 Hertz on top and the 150 below. And so instead of the CDI needle for our localizer, we're going to be using the little green caret that's going to be just to the left of the tape of the altimeter. I'm going to keep them both centered, so if one gets high, like for the glide slope, if it starts rising, then we'd want to level off our descent to intercept it. Or if it falls below us, we need to increase our descent. And if the CDI goes right, then we fly right. If it goes left, we fly left. Service volume, up to 18 nautical miles. The course width is 10 degrees, and within 10 miles, it's course width 35 degrees left and right. It gets increasingly sensitive the closer we get. So as we're getting closer to the runway, it's important to make smaller adjustments, because it's going to change rather quickly. You can see this diagram here of the G1000 where it shows the localizer on the HSI and the glide slope on that tape left of the altimeter. So the course width is pretty narrow. It's typically only 5 degrees, which results in the high needle sensitivity. So full scale deflection is only 2.5 degrees either side, left and right. The glide slope is a building which is going to be about 750 to 1,250 feet down the runway from the approach end, and it's going to be off to the side about 400 to 600 feet to one side of the center line. Whereas the localizer is going to be past the departure end, centered with the runway, obviously, because we need to be centered with the runway. And we can see that in the diagram here that's next. It also shows the marker beacons and the frequencies used and distances. So getting into the marker beacon, first is the outer marker, which is blue in color, and it has dash, dash, dash. It's typically, for the Morse, it's typically 4 to 7 miles from the airport, and you can expect to intercept the glide path, or the glide slope there, and usually we're around 1,400 feet AGL. The middle marker is amber color, and that's going to be dash dot for the Morse code, and it's about 3,500 feet from the landing threshold, and we're usually about 200 feet AGL from here. So I mentioned the 3-degree glide slope. However, 2.5 to 3.5, or 2.5 degrees to 3.5 degrees is what the ILS is set to depending on each airport. So it's going to be different in every airport you go to, just based on the needs of that airport. Or even runway. I mean, the same airport with multiple ILSs to different runways could be different. So there are false glide slopes that may be encountered. Typically these are seen when there's terrain or obstructions that get in the way and reflect the signals above. So a false glide slope is only ever going to be seen above the real glide slope, so it's important that we intercept from below. So by intercepting by below, by following the altitudes on the instrument approach procedure, we should see the glide slope coming alive. Well, the needle should, or the caret in this case, would come to the top of the scale and then it would come down to center. And that's important because we know that's going to be the real glide slope that we need to follow. And by following normal maneuvers, we should be able to descent rate normal maneuvers, we should know that we're on the normal one. Now, let's say we're way high and we are chopping and dropping and trying to lose altitude. So that CDI needle is coming from below and rising up to center. Well, if we could be on a false glide slope, they typically occur at the 9 degree and 12 degree. So if we're using crazy maneuvers and crazy descent rates to maintain the glide slope, then we're obviously on a false glide slope. We need to go missed. It'll get us to the same spot, but it's at a very excessive and dangerous glide slope, which the FAA published many studies about how descending faster than 1,000 feet per minute leads to very increased chances of disaster, just because your aircraft's not in a stable condition. So times to execute a missed approach. Begin the missed approach, well, we'll begin when the 3/4 scale deflection occurs on either the glide slope or the localizer. Either of those both warrant a missed approach. If we do find ourselves exceeding 1,000 feet per minute descent rate, we need to execute missed. Unstable descent rate or maneuvers require missed approach, and then once we get down to the decision height or decision altitude, and we do not meet the standards of 91-175, we need to go missed. And if we descend below the decision height or the decision altitude, and we after that point lose visual with the runway, then we need to go missed. So the cool thing with an ILS is rather than, or the precision approach rather than a non-precision approach, instead of a minimum descent altitude and then flying to the missed approach point, we are going all the way down to our decision altitude or decision height, and that is where our missed approach point is. And so that's going to be the point at which that we execute our missed approach. And it's typically lower because it's more precise. So 91-175 gives kind of three things that need to be all true in order for us to continue our descent below the DA. And that's going to be that the aircraft is continuously in a position from which a descent to landing on the intended runway at normal rate of descent and using normal maneuvers can be accomplished. Second, the flight visibility must not be less than that prescribed than in the standard instrument approach being used. And then one of the following visual references must be distinctly visible and identifiable to the pilot. So first is the approach light system. I mentioned that that's going to change with every runway, so at the very top of our approach plate we can see what those lights may be for a specific runway. Now the caveat to this is that we cannot descend below 100 feet above the touchdown zone elevation unless the red terminating bars or the side row bars are also visible and identifiable to the pilot. So we can use the threshold marking, threshold lights, runway end identifier lights, FASI. We can use the touchdown zone marking, touchdown zone lights, the runway markings, or runway lights. If we see any one of those, we can continue our descent below DA and not go missed. So, let's see. Common errors here. We have a failure to understand the essential information on the approach chart. Failure to recognize conditions requiring missed approach, we just went over. Not promptly initiating a missed approach. Not making the required report, so it's always climb, cram, clean, communicate. So we always need to let ATC know. That's a mandatory reporting point. We need to tell ATC that if we're going missed. Let's see, we need to comply with the approach procedure. So it's important to have the initial actions for the missed approach memorized, and then immediately follow those. Now, of course, for us doing practice approaches, the majority of the time ATC is going to assign climb out instructions, which they will tell you if that's what they're going to do. And then the big one is once we hit the decision altitude or the decision height, we don't meet 91,175, we must go missed. And so a big error is descending below that point. That's a hard altitude. I mean, you can't be a foot below that. So continuing that descent a little lower is a strict bust. So for the ACS requirements, we need to initiate the missed approach by promptly adding the power, establishing the climb attitude, and then for our 172, we'll go 10 to 0 on the flaps for our clean. Then we got to report to ATC that we missed the approach. We're going to comply with the missed approach procedure or the climb out instructions by ATC. Let's see. We'll conduct our climb checklist once time permits. We need to maintain the airspeed plus or minus 10 knots, heading, course, or bearing plus or minus 10 degrees. Altitude is always plus or minus 100 feet. For the missed approach, of course, on our inbound from final, it's plus 100 minus 0. And then before the final approach fix, it's plus or minus 100. A good one for situational awareness is the multifunction display energy 1000, because that shows all of the next pertinent steps. So I mean, that'll give you great situational awareness. Now, of course, we can't fly by the MFD, but it helps with situational awareness so we can see exactly what's going to be coming next. Plus, with that flight plan enabled, it will tell us exactly what we're doing next, in addition to our approach plate. And single resource management, so that's a big one. Single pilot resource management, utilizing all these tools to maintain safe and accurate. And that should about cover it. And the last thing would be for the instrument approach. We have the one here in Las Vegas, which we'll use here. And for the ILS, not good at these things. Okay, let's see if this works. Okay, so we can see the ILS here, and at the very top in the center there is typically where it will say what our approach lighting system may be for this runway. Now you can see if we're here, we don't have one. We just are lucky enough to have a PAPI. And for our weather altitude, what's prescribed down here, we can see the 301 in the parentheses is telling us we need 300-foot ceilings and we need 1 mile visibility. And our decision altitude there is going to be the 2456 for the ILS, which is 267 feet above the touchdown zone elevation. Pretty awesome. All right, thanks for listening.